Hello.
Hello.
Yeah.
Woo. Friends and family, welcome to my wedding. Oh,
You're clapping because after this, it's dinner time,
yeah.
right? Yes.
just one more to get through, but it's not any talk. This is the Dustin and Madge show.
Yeah.
4th year in a row or something like that?
Something like that.
Something crazy. We can't count that far. You see, I have only 4 buttons on this. That's as far as I can count.
Yeah. I've got a whole keyboard.
So introductions, I guess. Meet my friend Dustin.
Hi, I'm Dustin. I am a, architect-y engineer on C# compiler and on C# IDE and all the C# tooling. I spend a lot of time looking at and thinking about, and mostly I'm a meddler. I like to say that I meddle in a lot of different projects.
You always have so much to say about yourself. Hey, I'm Madge Torgerson. I'm a PME kind of designery type. I like to design languages. I'm sorry. That's where we go. Okay. So once again, we're happy to announce this is becoming traditional. C# has a future, and we're going to talk about it.
Someday we won't say that, okay? And you'll be really sad.
That year, this is also how, this is job security. This is how we make sure that they keep us up here year after year, because what'll happen if there's not the future of C# talk? There'll be, the peasants will be revolting. So we do get the feedback sometimes that you called it the future of C#, but you didn't talk enough about the future.
Yeah.
And we did a lot of stuff. Like this last year, we shipped 3 versions of C#. They're minor versions, but there's a lot of features in them. And we do want to show them because most of them weren't even around when we were here last year. So we do want to show them. But we also want to be respectful of the people who actually trusted the title of the talk. And we're going to spend the bulk of time talking about and actually showing a bunch of prototypes of features that we think might go into C# 8 when that comes around. Okay? So the bulk of today, or more than half at least, will be in the future. And the vast bulk will be spent in Visual Studio, which they don't let me into anymore, so it's Dustin doing all the typing. Before, though, I get to say a few PME things, but I expect about an hour in Visual Studio. We won't probably have time for questions at the end. We'd like to, but you probably want to hear about that last feature. So, this is the last talk in here, so just catch us afterwards if you have a burning question. We'll actually both be at the C#, VB, and F# booth in the Expo Hall tomorrow morning when it opens. At 8:30 we'll be there.
8:30, that's right.
I don't know if it's even open then, but that's when we're supposed to be there. So the whole morning you can come and talk to us there as well. So if you have questions, that's your go-to approach. Okay, without further ado, let's do the also by now traditional look at the GitHub developer survey, which always comes out shortly before build.
Stack Overflow.
What did I say?
GitHub.
GitHub, that's a different thing.
Yeah.
The Stack Overflow developer survey. Yeah, we can edit that out after. The people in the future, they won't see this. So this year, they do most popular languages by use. Some of those languages aren't really programming languages, though I hear that SQL is... No, really. This is just my definition. HTML, I'm sorry, it's not a programming language. I'm going to cut those out. I did keep JavaScript in there. I'm trying to be fair. And as traditional, C# is one of the top 5 languages per usage. According to this survey, which has all kinds of bias, and there are all kinds of ways in which you should take it, was probably a metric ton of salt. But still, it's good. We're still a very popular language. And then they also check how much do people love their language. Like how high of a percentage of the people using it would like to keep using it. And we're also on the top 10 there, a little further down, but we're doing well here. And we've been sort of consistently on both of these lists, and that warms our hearts. So one thing to notice, though, is that it used to be, a couple of years ago, it was just us and Python that were on both lists. We were both popular and loved at the same time. And then last year, TypeScript joined the ranks. It was loved for a while, and then it became, it got enough usage to hit the top 10 of popular. So happy to see TypeScript there. This year, the 2 more languages are coming into this prestigious set of languages. There's Swift, which is another language that people have loved since it came out, and now it's accumulated enough usage that it is on that other list of most popular languages. And then JavaScript. And so we think a lot about why are we here? Why are we on this list? Why do people like C#? And we have this theory that it's because we keep the language modern, we keep it fresh, we actually are willing to evolve it. So professional developers will rather have more new features to learn, but then have more productivity and more expressiveness and features that are more apt to deal with today's problems, rather than have a language that's simple but doesn't really fit the world anymore. So we are happy to aggressively evolve C#. We've always done that. And I think that more and more languages are also doing that. If you look at JavaScript, you can write large bulks of code now that actually look nice, because you have really accomplished people working on JavaScript and evolving it rapidly and putting features in to take the horrible away. We can't take it away, but give you alternatives to the horrible. And so I think it's interesting, but it's sort of confirming that the strategy we're on, we can't always be the only ones doing this, but the strategy that we're on to actually keep giving you the features that you need, going with pushing the state of the art of programming languages and also going with new scenarios, that's a strategy that we should stick to. And so if you go look at the strategy that we published about a year ago, I have it here almost verbatim. It really summarizes that, and we're going to stick to this fiercely. We will keep growing C# to meet evolving needs. We will innovate aggressively, so come up with new things in order to address these new scenarios while trying to stay true to the spirit of the language at all times. Given that C# is used for many, many different things, the developer base is insanely diverse. We will prefer improvements that benefit most or all developers instead of focusing in on a particular scenario or a particular layer of the stack or whatever, particular platform even. And finally, we'll continue to empower the ecosystem so that we have the whole community play a role in the future of this language, while at the same time taking our leadership seriously and being strong stewards that make the final decisions, keep the language coherent, and don't let it sort of die a death of design by committee or something like that. So this is pretty much trying to summarize how we've always thought about C# evolving. Yeah. Maybe with that fourth bullet being a little newer, right? That's the whole community involvement is something that we had to learn first. Okay, so enough about that, enough PM talk. Now we're going to actually start looking at what did we do. We shipped 3-point releases since last year, 7.1, 7.2, 7.3. We don't usually ship point releases, but we thought, what the heck, that would be fun to try. And so we kind of went a little overboard and did 3 of them. There was a particular scenario that drove us to it, which was this desire to have safe, efficient code in some places where it's hard. It was hard in C#. Places where you, especially in the lower levels, but not necessarily system level or a little above, but also in all performance critical code, avoid garbage collection pressure more, avoid copying, unnecessary copying of data, while not having to resort to unsafe code, while staying completely safe. So that was a big theme. And then we have some more things that we just trickled in to give you more freedom, allow more things that used to be forbidden, or say things in a shorter way. So we have about 20 features to show you across these 3. And we're, to hold ourselves to the timing constraints that we have, we're going to try to do 20 and 20, okay? So 20 features in 20 minutes.
This is to make sure that we get the future stuff, right? Yeah.
Are you ready?
Let's flip over here.
Okay. I was actually asking him, but
yeah,
are you ready?
Yeah. I was born ready.
All right. We're counting. 20 minutes. Go. First of all, Dustin, what do we have here? We have a
really simple program that computes the sum of squares. That's what we do in these talks.
Sum of squares.
Little tiny things.
Yeah. What can you for 20 minutes?
Yeah, yeah.
You can't do realistic stuff. Okay, but so let's start out by reminding ourselves of some of the C# 7.0 features.
Yeah.
Let's take the sum of squares method and make it async, because we anticipate that we'll want to take that very hard computation that's in there, and we will want to shell it out to maybe another thread on the thread pool. And so in anticipation of that, we asyncify this method.
Right.
Now,
so then we got to weight it, right?
Then you have to weight it.
And then that's...
You can't do that because you're not in an async method.
Right, but that was something new, right?
Yes, so here comes something new.
Yeah.
So something we did in 7.1 is that we allow you to make the main method async. Returns a task. Yes.
The great thing about this is when we showed it last year, it was a lie.
Yeah.
Right? We did that, but we didn't compile it to show that it failed.
It doesn't actually squiggle it.
But it really compiles now, I swear.
Yeah, it really works now.
Yeah.
Yeah, because we were still in a prototype back then. This is production code. Okay, so next thing though, it's an async method. We also want to have a cancellation token.
Sure.
That's the next thing, right?
Yeah.
So cancellation token.
And then we'll make a default.
The default.
So that it's optional. And then this is another feature that we introduced, right?
You don't have to say the type.
Yeah, you don't have to say the type after default. You don't have to say.
It's in context where the type is given.
This is so redundant, right?
You don't have to say cancellation token again because you just said it.
You just said it.
Okay.
In fact, we'll gray it out and make it.
Wherever you assign default or pass it to something that has a type, and just say default.
Okay.
Okay. Good. Yes. Small feature, but definitely worthwhile.
All right. So next, you want to talk about small features? This is a small feature, right? So we had digit separators and binary literals in C#7, right? And we also introduced this one little thing because when we did digit separators, we forgot to let you put a digit separator here
between the base and
right here.
And the number.
So you're welcome.
Well, it's squiggling it because
it is squiggling because this is a feature that's actually in C# 7.2. So if I go ahead and upgrade this project to C# language version 7.2, then the squiggle goes away. So usually when you use these new language features, we try and give you a way to say, oh, you know, I want to upgrade my project, or maybe that's something you say, oh, well, I'm not really ready for that, and I can back off from doing the feature. But in a way, you get a way to easily upgrade things. So
now we're in 7.2. What's next?
So next, I think we should probably go and start implementing this. I mean, right now, some of Square's async is got a squiggle because we're not actually doing async-y things.
Yeah, so actually get that work offloaded to the thread pool.
Right.
Okay. So back when we did async, we supposedly made it real easy to put things on the thread pool with a method called task.run.
So I'm going to go ahead and turn this into another feature that was newish, you know, at C#7, which was
local function.
Local function. And then we can just return that. Actually, though, we should probably now we can put this in a task.run.
Yeah, let's task.run it, which is a method that takes a delegate and an optional cancellation token.
Yeah.
Which we should also pass in that cancellation token you took before.
That didn't work.
Yeah. So now we have there's an ambiguity here.
That's an immensely unhelpful error message at the bottom.
That's very bad. Did you see the error message there? It says
holy smokes.
It can't choose between one that takes a func of t result, which would be instantiated to the int here, or one that returns func of task, or a func that returns a task. Well, we're not returning a task. So what's the problem here? The problem is that since C#1, we had this odd thing with overload resolution that when we picked the candidates, the things that fit, there were certain things that we didn't test for. Instead, we would go and choose the one that fit best, that had like the closest types or whatever. Once we had a pick, we would say, yeah, this is the one. Oh, it doesn't work. We give you an error.
Yeah,
right? So,
you're welcome.
So either you get that error, or you have an extra candidate in play that is useless, and you get an ambiguity error, which is what's happening here. But in C# 7.3.
Woohoo, which doesn't have a fix yet, but that's fine.
Which you can go and update to in the...
I can just open up the project. These are all
work.
Yep.
Yeah.
Save that to C.
We're fixing this design bug, you could say, that's been in C# since 1.0. Sorry, Anders. And now we actually take the candidates that don't apply and we weed them out beforehand. Task.run, people have been complaining about this all the time, where the return types of a delegate don't match up. The other places where this applies are static versus instance. We didn't check that before. So you could get like an instance method when you were calling statically and an error. And also constraints. We didn't check that type parameters or type arguments actually fulfilled the constraints and the type parameters. So we do that now before you even get play.
Yeah, and this is oh, sorry, was it? Yeah, that's exciting.
Did you like that? Is that okay?
Sorry. I've never heard applause for overload resolution before, so I was just surprised. Taking it back.
We might try to make overload resolution better every year, and nobody ever applauds. So
nobody ever applauds for it, and we're actually running out of superlatives. I think we called it like, you know, because the rules are called betterness rules, right? Where we pull these out, and so we had like betterness, and this was bestest betterness.
This is called bestest betterness. Yes.
Yeah, internally. So.
Okay.
Yeah.
Yeah, but the clock is ticking.
The clock is ticking.
So we also did a few other random things. Is time for those?
First thing, almost. I should pass the cancellation token in here.
Yeah.
I would like to show yet another nice little feature, which is, you know that when you pass named arguments and you have to always, once you pass a named argument, even if you want to put it on like a Boolean literal like false or true, just to give it some documentation, and now you have to take the cost of naming all the rest of the arguments, even though it seems really ridiculous. That was ridiculous. And so you can now, in which version? C# 7.2, I believe. You can name an argument, and I don't have to name this argument, right?
So if you have an argument that you kind of want to call out which parameter it's going to, or you actually do it for overload resolution purposes to disambiguate, you can now do that. So that's kind of small.
Yeah, this is what it used to be. This is what you can do now.
Yeah.
So you're welcome.
Okay.
All right.
Now we had a trickle of complaints. We're going to write now the most useless.
Well, so this is kind of fun because before I was at Microsoft, I sent a request through the Microsoft Connect site, if anybody remembers that, for leaving feedback externally. And my feedback was all about enums and why isn't there an enum constraint for generics? And I got a very nice response from Mads Torgerson, who was new at Microsoft, about it really. I should stop worrying about it, and it wasn't a big deal, and all that. That was 10 years ago.
Yeah. So there's been a trickle of requests even after Dustin joined Microsoft. So there are these types that, for random reasons,
we just never
you can't use as constraints, and we just removed that restriction. So now, if you want to put a delegate constraint or an enum constraint on your type parameter, you totally can. It doesn't mean anything special. It just means that it derives from that type. So it's not necessarily an enum just because it could also be system.enum itself, but it's still helpful.
Right. So we removed that restriction.
Those members. Cool. So this was just removing a restriction, but we also added a genuine new kind of constraint.
Yes. So if I wanted to take this, the constraint is around, if I recall, this sort of situation where I want to be generic, but I want to
take a pointer.
Generic around, excuse me, pressed the wrong key. I want to be generic around pointer. So this requires me to go ahead and be unsafe as well.
Yeah.
But I want to do this.
It's the one unsafe feature today.
Yeah, this is not possible. I can't take the address of, get the size of, or declare a pointer to be a managed type T.
Yeah.
Well, that just seems very restrictive.
But if you can't be managed, well, then put a constraint on it saying it has to be unmanaged. So now you can write generic code over things that you can take pointers to, which is the concept of unmanaged from the C# language specification. And now you can take a pointer to it, and you can do all your pointer gymnastics in a generified way, which is one of the abstraction mechanisms that have been unavailable to unsafe code in the past. Now you can do generics over it and probably unify a bunch of repeated code in all that unsafe code that you shouldn't have.
Yeah.
Okay. So that's sort of the random grab bag of things.
There's also tuple equality.
Oh, yeah. We have a few things with tuples.
Yeah.
Let's declare a tuple.
Okay.
Var tuple equals, I don't know.
Like D from the delegate.
D is up there. Math.py is good. Okay. Yeah. So here's a tuple. In C# 7.1, we made it so that, because tuples can have optionally can have names on the elements, and if you hover over the tuple here, you can see that now, if you don't give names explicitly, but the expressions have names, then it'll just pick up the obvious name for the tuple elements. So this tuple will actually have the name D and the name pi of the two elements. So that's kind of helpful. Also, we implemented the equal and the not equal operators over tuples. They didn't actually have those before. So now you can take this tuple and compare it to, say, some tuple literal.
Yep.
With equals.
So say like null and like
null 42.
Yeah.
And actually, how that works is it does the comparison per element, right? So it doesn't. So the two sides don't have to be exactly the same tuple type. Indeed, the right-hand side of this equality doesn't even have a type as a tuple because one of the elements is null. But you can still compare them because pairwise, the equals operator exists and applies and works out. And so the compiler just breaks it up into the individual equality comparisons with the obvious
Yeah.
short-circuiting ending in between.
I would prove it, but I have no idea how to call this method.
Yeah.
Ridiculous.
Yeah. Let's. I think this is the most useless method. This is the second most useless method
This is
we'll
the
show.
glom a bunch of features
And-
onto a method at the end of the
Yeah.
demo talk.
And the most useless, we're not going to tell you which one that is.
Yeah.
But let's switch gears then to talk about refs.
Yeah.
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 So refs have always been in C# in the form of ref parameters. You've always been able to pass things by ref. And so here's an example of a little method called or maybe that takes two parameters,
Yeah.
mutates them, and then returns one of them.
Yeah, they're not actually, but it's not, so I can run this and it's printing out A, B, and C, and that's what it gets. You get 1 and 10 and.
And of course, it passes things by value. So so X and Y are copied across, or A and B are copied across to X and Y. But you can use ref parameters and have been able to since C# 1.0. And then you're actually passing not the contents of the variable, but the variable itself.
And I have to update this.
So that now that you have to acknowledge when you call that you're doing this, because this allows the callee to modify the variable that you passed in, right? So you're giving it the keys to the kingdom, so to speak. You're giving it access to something of yours.
Right. So since it modifies A now, when I run it, you'll see A too, right?
So it actually
before.
So the mutations work back to the original variable. So that's old stuff. One of the things, so refs are useful not so much for ints, I guess. It's just a very small little value type. But sometimes, in order to avoid allocation, you'll have big value types. That's common in game programming, for instance. You have big structs, and passing those by copy is out of the question. But you have them as structs because you don't want to allocate, and so refs are really important there. And we're gonna really do things with refs now. The first thing we're going to do is that you were never able to in C# to declare to make an extension method that takes ref as its this parameter.
Well, that's bizarre. Why would we do that?
Well, you want to do it because you want to.
Oh, yes.
You want to allow the extension method to mutate the struct itself, not some copy of it that you then throw out, right?
So like a typical extension method now, this call site is still legal. I can still call it as a static method, but then I can also
But now you can
call it off of A itself.
call it on A as an extension.
Yeah.
And now it mutates A itself.
Right.
So that wasn't possible before.
Right.
That's kind of
in fact, it does. It does. In fact, I'm going to compile them. It does exactly the same thing.
Yes.
So.
Yeah. Nothing changed there. Let's see the next thing.
So the next thing on the list that I have is in parameters.
In parameters.
Yeah.
Okay. So we have out parameters and we have ref parameters. Okay. Out parameters are like ref parameters, except that the callee is obligated to mutate to assign something into the parameter. Okay. Now we're adding in parameters, which is sort of the opposite, in that the receiver is obligated not to mutate the parameters. So it's a sort of a read-only ref, if you will. So if we change the declaration of y to an in parameter, it's still by ref, but it can no longer mutate it. You get a squiggle under the y minus minus there because it's no longer allowed. And so this gives you a way to pass things by ref, which is efficient, but you don't have to worry about that thing you were calling mucking up your own struct. Okay? So you get the efficiency without the risk.
Yes, and we also broke the call site.
Yes, and so now the call site can't say ref anymore. It has to
say
it has to say in. But now actually because in is safe and it's sort of like passing by value but more efficient since you don't have any risk to opt into, you can actually optionally omit the in keyword and just do it like a normal value call.
Right.
And when you do that, you can even you can even pass a value, not a variable. And then the compiler will create a local variable under the hood for you that contains that value and pass that variable by ref to the.
There's so much by ref happening here.
It's a lot of referee.
All ref.
Yeah. So so that's the ref on the parameter side.
Right, and so we can also do ref on the return side, right?
Yes. So in C# 7.0 we added ref returns as well. So you can actually return a ref.
There's two refs on that.
Yeah. So now you're returning a variable, not a value. You can see that the call site is still valid because it returns a variable, but we're immediately reading the value out and copying it into the int variable C.
Unpack it down there.
But we can actually take the ref to the thing that comes back, and we can oh yeah, you have to return by ref there. Yeah.
Yep.
So in the call side, you can now put ref on the call.
Yep.
And then you can declare your local variable as a ref local.
Right, and as you were saying, sorry, I kind of jumped ahead, but the copying, right? If you don't want to copy, you can put ref on the call
Yes,
side
exactly.
and
Yes.
pass that on through, and then this also has to be declared.
Again, this is more of an efficiency booster if the references weren't actually twice as big as the ints that we were copying around. But
And I'm not really
use your
sure,
imagination here.
I'm not really sure how any of this works. I just see that if you pepper ref throughout your code, it's supposedly more efficient.
I hope we do a better job than that at explaining this. So now that you have that, though, now you can assign into C,
Yes.
which is now an alias for the variable that was returned, which was an alias for X. So now when you mutate C,
which was A passed
A,
to the
yes.
receiver. So
A-
really, C and A are the same thing now.
the same variable, you
Right.
mutate one,
So
the
I
other
can,
one
I
gets
can run it, and
mutated as
I can
well.
prove it to you.
Yeah. So
Very exciting.
So you can do things that are very confusing. Okay. Now, if I don't want to be so confused, let's actually try and take the X parameter and also make it an in parameter instead of a ref parameter.
Okay,
That's a thing now, right?
I think that's a thing. Okay.
And now, of course, we can't mutate X anymore either in there, but more interestingly, we can't pass it by ref because we just promised that it was an in parameter. We weren't going to mutate it, but by returning it as a ref, we're letting somebody else mutate it, which is breaking our promise, except if you're a lawyer, but we're doing languages. But you can return ref read only, and that's where you pass something back to your caller, but saying but you can't mutate it. Sorry.
That's
But
awesome.
you get to
Another
look at
keyword
it.
with R at the beginning. That's awesome.
Okay. So now we don't get to assign it into a ref local anymore, because if we did, then you could mutate it, and we actually do mutate it. You have to make the local ref read only as well. So you can see we're kind of pushing this read onlyness through. And now finally that mutation that we were trying to avoid all the way back through this whole call chain, now that becomes illegal and gets a squiggle.
Yeah.
And so you can see how the whole system actually protects the whole read onlyness.
Is it really protected? Because A and C still point to the same thing. So if I rename this to A,
You can assign to A.
and then I'm still assigning to C.
And you can, yeah, sure. But that's because you have write access to A, and that's fine. A is your variable, but the method didn't know that it was. You didn't know that it was the A coming back.
Yeah.
So. Okay, so
we can also reassign these things, right? That's new.
yes. So the ref. So this is all 7.2 stuff, except that the ref locals can also be reassigned. So we can actually change our minds about what variable C points to, and we can create a D, and we can assign that by ref into C, and now C points to D instead of to A.
Except it's not allowed because it's a C# 7.3 feature. So let me go ahead and
Yeah. So you have to update
brand
to
new.
7.3. Yeah. This is brand new, and occasionally useful.
And now they don't point to the same variable at all. I still assign to A, but C is now pointing at this other local D.
Yeah.
And
Yeah.
So if I change D, that would affect C.
And I don't want to get too much into this, but we do a whole lot of static checking to make sure that we don't bleed out references to things that don't exist anymore. So the ref is never dangling.
Yeah,
And
so
there's
for
a lot
example-
of compile analysis that goes into that.
Yeah. So for example, here I get an error because the scope of D is within this block, but C is just greater, and that would bleed out. So we have all sorts of escape analysis and things happening to under the hood to make that work.
Good.
All right.
So on to span.
You want to do span? Okay.
Isn't that?
There's ref conditionals if you like.
Yeah.
It's weird.
Yeah, it's
okay.
weird.
It's already weird.
They're already a little weirded out. I can feel that.
They're like, guys, come on.
Let's skip the weird and go to the outright crazy.
All right.
So, if you were in here the last talk, they talked about Signal R and Kestrel, very, very efficient frameworks at the bottom of the stack that are implemented in C#.
Mm-hmm.
And how they do that is through all this ref stuff that you saw now. So it's not just academic; it's really being used, and also through a new type that's called span of T.
Yes.
I think the best way to introduce it is to, if you go and look at an array, here we create an array, we initialize it, and we print it out. If you look at that array, it actually now has a new extension method on it.
Yep.
which is called as_span, and that returns the array as a span. So what is a span? A span is like a window onto an existing chunk of memory, like, for instance, the chunk of memory that an array represents, a contiguous span of variables of the same type. Okay? So that's what an array is pretty much. So a span is a window onto that. It doesn't have its own memory, but it's pointing to somebody else's memory. So now we have that, and if you
We'll go ahead and
so
run
now the span is just has the same elements as the array.
Yeah.
Even actually, if you create the span before you initialize the array,
Yes.
by moving that line up a bit, you can see you still, and you write out the elements of the span, you can see it still has the initialized elements because it's actually looking at the array, not a copy of it. Okay? So it's a representation of some memory that it's actually very much like a ref, except it's for multiple variables, not a single variable. It's for like an array of variables, essentially. Okay?
So we can also slice these things, which is probably
Yeah, so
one
now-
of the more interesting things. It's kind of cute to have a span that's exactly the array, but really when I want a window, I want to look at a piece. Often I want to look at a piece of an array, right? Or a piece of a span, right? Some particular range within that. And so I call it splice, which was foolish because that's not what it is.
No.
And we'll
It's a span that's a slice. It's kind of
sure,
a slice.
we'll say that. All right, and I can iterate over that. Now I've got just
Right.
the pieces of it, starting at index 3 with a length of 5.
Right. And that, again, is even, so again, it's a window onto a part of the array now. But you saw we still only initialize the array after, but it still looks onto those same elements. There's no copying going on. So it's an important way of representing memory and working with chunks of memory without copying, which is great for low-level stuff. And we can even change the initialization here. So instead of initializing it through the array, we can initialize through the span because the indexer is writable.
Yeah, it's actually, if I,
Yeah, the indexer is really funny.
yeah, it's actually,
We laugh at these things, you know.
Yeah.
Oh, that's a funny indexer, you know.
Yeah, it's silly.
Pretty much saves the week.
but it's actually a ref return as well. So when you get it, you're actually getting a ref to the thing that was inside
Yes.
the span at that index. And so when I assign into it, I'm assigning right into that the particular array, so there's no copying going on.
Yeah, the crazy thing is that even though you can both read and write through the indexer, it doesn't actually have a getter and a setter.
Yeah.
It has a ref getter, gives you a variable back, and then you can read or write that variable. It actually points straight into the array. That field in the array, that element in the array, this variable here, I can read from it and I can write from it through the ref that I get back from the index. Indeed, I could take the indexer return and ref assign it to a ref local. It all comes together. Like these features I just show you, they work well with span.
Yeah.
So again, no copying. Of course,
We can do, we also, the one thing about span, well, the one thing here is that because we're assigning into it, that might be a concern. I might want to have a read-only window.
Right.
A read-only view on this.
yes. So just as we did with the refs, we wanted the read-only refs. You also have a read-only span, which a span can be viewed as a read-only span, and then it's a protected window. It's like a closed window,
Right.
You can't reach through because the glass is there. You can't reach through and change things. You can only see them. You can see them change, but you can't do anything about it through a read-only span.
Right, so I can no longer assign into it.
Yes.
So I have to go back to the original array that the span is pointing to and assign in there.
Okay. So, but using span just for arrays is kind of a little lackluster.
It is kind of
I think
weird.
it really comes into play is that span can represent other kinds of memory. It's a great interrupt type, for instance, to represent unmanaged memory, some buffer that you get from interrupt with unmanaged code, for instance. It's built for handling that. And also, you can stack allocate a span, actually. So instead of creating the array first and then making a span over it, which does a heap allocation of an object that will get garbage collected sometime in the future, we can actually create the span itself
This is one of my favorite things because I'm using
directly on the stack.
I'm using
right here. Those 10 elements,
Sorry.
they will sit right here in our stack frame. They'll just get allocated out of the stack frame that you're in right now. And you can do exactly the same thing. So I can pass it on to other methods and work on this. And when I return out, then that.
Yeah. The beautiful thing here is
Right.
that I'm using the keyword stack alloc, and I did not make this unsafe.
Yeah.
Right. This is perfectly safe.
So again, if you think about, if you worry about allocating little arrays all the time, well, maybe stack alloc is a better solution, at least of small arrays. The worry with stack alloc is if you do it all the time recursively with big stack allocations, then you just blow the stack instead of trying to avoid garbage collection. You have to, be judicious about it. So that's span.
Yeah, that's span. We're actually right at the end of the 20.
You're kidding me.
No, I'm not.
We did this in 20 minutes?
Totally.
Okay.
We're wasting time now.
We should have made it harder.
Yeah.
Okay, well, there you go. 20 and 20.
All right.
Huh.
Well, this was all fun because this was Visual Studio 15.7, Visual Studio 2017 15.7 that we shipped yesterday.
Yes.
And I'm in this little folder called Demos. I'm going to go up a folder, and here's a folder called Future Demos, which should be tantalizing. And these folders all represent different possible instances of Visual Studio with different prototypes in them. So yeah, there's a lot of potential points of failure.
Right.
Okay? And that's okay. You guys like that. I know you like that.
So I want to say up front, we are demoing 4.5 new features.
Oh, yeah.
And 3 of them, the previews we are showing, are actually publicly available today. And you can go and play with them yourself. They're rough prototypes. They're not like your usual release candidate quality, but we'd love for you to do it and give us feedback on how well these actually work on your existing code bases, if you're willing to turn them onto your existing code bases, and help us get this right. Because we have time before C# 8 ships, and we want to get these features right.
Right. And we want to show Nullable first, right?
Yes. So let's start with one that we actually showed last year as well, Nullable reference types. Which nullable reference types, aren't they already nullable? Well, we'll get to that. But the idea here is, for those of you who haven't seen it yet, it's probably many of you, the idea is that, so essentially, popularity contest here, how many people in here love null reference exceptions? It's just your favorite thing to have happen. That's very few. There's always one somewhere. Luckily, I can't really see you because of the light. There's always one who goes like, I just wanted to attract attention to myself. But it doesn't seem like, okay. But null reference exceptions really suck because it's a problem in your code that it's hard to know about before it happens, right? And it happens, so the problem, the original bug is probably somewhere else in your code, right? You put a null somewhere you weren't supposed to. Later, you dereference it in a place where you didn't expect a null, and boom, who's to blame?
You were. No, I'm sorry.
The language designer is to blame. That's
Our
right.
fault. We're sorry.
So I'll make it up to you now, and I'm going to solve that problem. We're going to deal with null reference exception, at least most of them, at compile time, at design time now. Okay, so that's a feature for that, which will tell you when your code is being unruly around nulls. The only problem with that is that we would want it to be useful, so we're going to actually have it give you diagnostics on existing code, which is something we've never done before because that's a breaking change, right? You get errors you didn't used to, breaks your build, you get angry. Okay, so this has to be behind a flag, and there's an opt-in for using the enforcement of this feature.
Well, there will be. Today, the preview.
Actually, the preview doesn't have the opt-in is installing the preview.
But there will be.
But when C# 8 rolls around, you get this if you choose to. It'll probably be off by default on existing projects and on by default on new projects or something like that. Okay. So here's some, if you look at the code up there, looks completely benign, right? We're creating a person, Miguel de Casa, then we get this, we call a method called get length of middle name, and we get the length of we take his middle name and we get the length of it and return it. Looks kind of all right, like no particular line stands out as troublesome, and there aren't that many lines of code.
No.
But of course, if we run it, boom, you have a null reference exception.
That's
right?
awesome.
Oh, wow, Miguel didn't have a middle name. Oops. It was null.
He doesn't have a middle name.
What's that?
He doesn't have a middle name.
He doesn't. He really doesn't.
He really doesn't.
I asked him. That's why I use him, because I remember to ask him. So what to do? We actually have the feature on here, and you don't see any squiggles. But let's go and look at the person class that is sort of the core culprit here.
Yeah, there's just one hint in the scroll bar. There's a little warning.
Yeah, there's a little warning there.
Yeah.
What does that warning say?
It says non-nullable property middle name is uninitialized.
Yes. So here's the thing. The first thing to know about this feature is that it sort of changes the philosophy about what a reference type is. And it says the reference types, as you know them, they are no longer supposed to have null in them. Sorry. We're banning null from string, from person, from object, from all your reference types. And we're going to tell you if you somehow put a null in there or leave a null in there. Like it says we're not initializing middle name, which is string, which is now considered not nullable. But if we go and initialize it to null, anyway, because we know better. We're going to get a different warning saying, hey, you're not supposed to assign null to a non-nullable reference type. So we redefined the existing reference types to be not null. And that solves the problem as long as you're willing to never, well, don't applaud yet. Because there's a lot of people going, there's a lot of people in here going like, well, I sometimes actually really like using null. Am I not supposed to anymore? Yes, null is fine. But you have to say when you want to use null. You have to express your intent. And so middle name is supposed to sometimes be null. Not everybody has a middle name. So let's go and say that. And the way you do that is not surprising if you know about nullable value types. You put a question mark on it, on the type. And now you said, and this is why the feature is called nullable reference types. It's because there's a new syntax in town to opt into nullability. And now it's null. Now it can be null. And we initialized it to null. So we set in our public interface, this thing can be null. And look what now happens in the code that's consuming it. It gets a warning saying, ooh, you might be dereferencing a null reference. Because it now knows that the middle name can be null, and it can warn you about it. So what can you do about it? What would you do today? Any number of different things, right?
Yeah, I'd probably check for null. Right.
C# has a million different ways of checking for null. Well, probably more like 7, but you know,
like
I'm rounding up.
Like that?
So you could do that, for instance. The warning goes away. Somehow, we can see that if you get to that return, then it's no longer null.
Another trick might be just to assign it to a
local variable.
Right? Like a local variable. And then we can check that local variable for null. And if it's null, we can make sure it's assigned, right? And so we'll assign this to like empty string, and then we use it down here.
So in this case, when you get down there, we always will get to the return statement in this version of it, but we now know that if it was null, it no longer is because there was an assignment to it. So there's a flow analysis that the compiler does. It looks at your code from the point where the nullable thing got introduced to the point where you're using and dereferencing and saying, hey, is there actually a path down here where it could still be null? No? Well, let's not give a warning anymore. You fixed your problem. Right? So you can recognize existing code rather than introducing some new null checking operator that you all have to use henceforth. It can see your existing null checking and say that this code is good. Even though that thing might be null, you're dealing with it. You've done good. You're null safe. Okay? So that's essentially the essence of the feature, really.
That is the essence of the feature. So
express your intent and enforce that intent both on the non-nullable and the nullable side, right?
Though we've done a lot of thinking about this over the last year. We've had a preview, we've gotten a lot of feedback. And often, you know, I've got this kind of written really conveniently using var, which half the room hates, I think, by the latest surveys. And that half of the room probably had it written like this before, right? And that can turn into problems as well.
Yeah, so part of this, so we'll keep honing this feature because we don't want you to get warnings that aren't useful. This code up there is perfectly null safe. Okay? Because even though it says it's assigning a potentially nullable thing to a local variable that says it can't contain null, we do the null check after. Right? So the code was always null safe. We don't want to complain about code that's null safe, even if it's not how you should write the code today. Like if you're writing this from you probably would put string question mark on that. But hey, sorry, until C# 8 comes out, you can't. And so we can't really expect all your old code to be sort of cosmetically upgraded just because the compiler is too stupid. So there's a particular set of warnings involving mostly local variables that are really, when you think about it, only cosmetic. They help you write better code, but they don't make your code safer. And we've given those a particular warning ID, a particular diagnostic ID, so that you can opt out of those, and they might be actually opted out by default, again, on legacy code. So we're actually going to make this particular warning go away, and a few others that don't really improve your null safety, and that just becomes noise when you come to this feature and say, hey, let me fortify my existing code, let me make it null aware and null safe. You get all these false positives that this code was totally safe. It was just written with the features I had yesterday.
Right. So the idea here is if I wrote this, I should still get the possible null dereference off of that. But
Yes.
just because I use these things normally here in this and I'm converting from, I had a string question here, and I'm converting over to a string local.
Exactly.
That shouldn't cost you on legacy code. Because as I wrote in here, I wrote string s equals null. That is a very common pattern, right? To set something to null and then do some computation and make sure it's assigned somewhere else. We shouldn't. That will become a blocker on legacy code. So we want to make it easy to turn those warnings off while you're porting something.
So another thing you just mentioned quickly, it's time to move on, but is that when around legacy code, if you have existing libraries that aren't annotated with questions, we don't want to, the first prototype sort of said, well, that must mean they're all non-nullable, right? So you could walk up to BCL to console a write line, we would say, ooh, it doesn't take null as this argument, but that wasn't the intention of whoever wrote console.write line. They didn't have the tools to express their intent. So we now have the ability to distinguish between old code that doesn't know about nullability and new code where the absence of a question mark really means non-nullable. And we use that in the prototype so that existing libraries that haven't been upgraded, they don't trigger warnings. You're as unsafe as you always were, but you don't get spurious warnings on it, even when the lack of a question mark wasn't really an expression of intent. It was just that was what I could write. Right? So anyway, that's enough about nullable reference types, but there is a prototype. Go use it. If you can tell us how it works on your existing code base and give us feedback, that can help us do the next round of honing, get rid of some of those spurious, annoying false positives, or maybe catch more cases that you feel are strange that it doesn't catch, so on. We keep honing it. All right, so you okay with nullable? Yeah?
Okay. It's getting there. It's getting there.
Okay, next thing. Now we have a real good old-fashioned object-oriented type hierarchy here.
Yeah, we got like person and professor and
professor
student. You always write these. These are
it's either points or persons. I'm sorry. That's all we get to do. Yeah.
So and then we basically what we do is we have this collection of people. I guess I'm in there. And we then loop over them and we print to the console something about that person, whether they're a professor, a student, or just a normal person like myself. And we use some of the C# 7.0 pattern matching and a switch statement with the pattern matching on the cases.
Right. So one of the things is that the switch statement is, oh my God, it's so 60s, right? It's like probably the most.
What is this, Fortran, Mats? Come on. No, I'm just kidding.
It's Koenig and Ritchie, first edition. It's just been around for a long time, 60 years or something. And you know what? It's a little heavy. It's a little long in the tooth. And so sometimes in a simple case like this, where we're really just switching and then producing a value out, it might be nice to have an updated version of this, maybe an expression-based version. So we build a prototype of that, which you can also try out.
And it uses switch, but it's backwards.
Yes. So we use the switch keyword on the person.
And I'm going to take off all the case keywords, and I'm going to replace these colons and returns with arrows because that's what we do in C#. It's fat arrows, or lambda arrows. You like them?
Lambda arrows.
Lambda arrows.
The function arrows.
Yeah. And so I'll just do all of those here. I'm going to put commas because this is now an expression. Semicolons would be bad.
Yeah, so there's a little work to do. It's a little different, but we think it reads better that way. It doesn't actually have the default keyword. Instead, you can, and you don't use that either.
This will eventually be a glorious.
But the discard works fine for the catch-all case here.
Yeah, this will be a glorious refactor in the future.
Yeah, so the whole thing from the person and down to that end curly semicolon, that's now an expression.
Yeah.
It's sort of like a conditional expression on steroids, really, right? It's an expression that chooses between different options depending on which pattern matches first, and then evaluates that expression after the arrow and returns the result of that.
Yeah.
So that really compacts things out, I think, and makes it handy in many more cases where, okay, I don't actually want to fill two screens with the cases.
Yeah.
With cases in the switch.
What do you guys think? Is it all right?
Is it readable?
Is it too ugly?
Yeah. We changed our minds back and forth on the syntax just last week. So these bits are hot.
We literally spent 2 hours convincing ourselves fat arrow should have been colon, and then we came back the next design meeting and spent an hour convincing ourselves to revert the change.
Yeah.
So yeah.
So another thing, though, is that patterns, the patterns themselves, which you now have in switch statements, switch expressions, and is expressions, they could be more expressive, right? We have type patterns, we have the var pattern, we have the constant patterns, but it'd be nice sometimes if they could dig a little deeper.
Yeah.
So we're looking at the second to last case there with the when
this
clause.
when clause, right? So I could, with this prototype that is totally functional, and will be available to them shortly. I could put braces in here indicating that I'm going to start actually matching and doing pattern matching against properties or fields in here, right? And so I can say, well, if last name is Campbell, and of course now this becomes redundant. It still compiles, it's still fine, it's just redundant. And so now that's the same thing.
Right, so what's really happening here is we call this a property pattern, is that you can put a pattern that says, that object that's coming in, take a pattern and apply it to the property last name. In this case, it's a constant pattern.
Yeah.
And apply it to the last name property of that person object. Okay?
Now I could also do that because one of the things you can do with patterns, right, is take some of these values that are in the patterns and actually bind them to names on the way out. And we have a pattern for that. We call it the var pattern for declaring a new variable. So I can match on first name and say, well, let's just stick that in a variable, and then I don't need to use p over here. Yes,
you don't actually need p anymore, and you can elide it.
Yeah, and I can just get rid of it there. And in fact, this one, because now we're no longer in a case statement, right? In a switch statement with a switch section here, we can remove this. That type is also redundant because everything coming in is a person. So I don't really need a match that it's a person. I could just make that the match.
Right. So now we just have a pattern that all it says is, I already know it's a person. I don't have to say that. All it says is a person with the last name Campbell and their first name FN. Which we'll put into a fresh variable in this pattern and declare that variable there, return a string that uses that fn, right? So it becomes more compact this way.
Yeah, and there's also one key point here is I kind of wrote it this way. There's no ordering to those properties necessarily, right? So I decided, hey, the actual match on the constant expression reads better if I put that up front.
Yeah.
Here's the match and here's the thing that gets popped up into the variable. I can easily move these around and it doesn't matter.
But it's a little verbose to do the recursive matching with properties, though. It gets long. So for types where you actually made the effort to provide a deconstructor, which remember, there's deconstruction in C#, and it's not just for tuples. You can put a deconstruct method in your own types and have deconstruction work on them. Well, if you did that,
so
now you get to use that in patterns too, which is new.
Yeah, so the deconstruction here is first name, last name, advisor. So that's the order they're going to be in. So I'll go ahead and say, well, we're going to have a var pattern in here, pulling out the last name, the first name. So you know what? I don't need the first name. I'm not even using the first name, so I'll just discard it.
Put the discard pattern first.
We'll pull out the last name, and then we'll pull out the subject. Okay?
Yeah.
And so now I can use these in here. Again, there'll be glorious refactorings for these eventually. Okay? And again, I can elide the P.
You don't need the people. You need the professor because here we only know it's a person. We're still checking the type. It's still a type pattern, checking that it's a professor. And if it is, it applies recursively the patterns to the things that you get from the deconstructor, which is the first name first. Well, we don't care about that, so a discard. Then the last name. We care about that, and we don't want to apply any additional conditions to it, so just use the var pattern to get it, the var pattern to get the subject, and use those in the body of this case here.
Yeah, I'm going to do the same thing in the next one because that's just kind of awesome. So
that one's awesome. Yeah.
This one is like also first name, last name. So I'm going to get the first name out. I'm going to go ahead and discard the last name. I don't need it over there. I do need the advisor, so I'll
go
get
ahead. The advisors.
I can pull that out,
too,
and so then we can use these here. And well, this I want to just do that, right? Yeah. And now I can elide these guys, and that's beautiful.
Fine, but there's actually we're still dotting.
Yeah,
it's actually we could do another level of recursion here where we say, well, that advisor, instead of getting a variable to that, we could dig in one more level, deconstruct that, ignore its first name, ignore its subject, and fish out its last name, and then print that one out. So recursive patterns are, in fact, recursive. They can be nested.
All right.
And, thank you. I don't know if you think it's readable, but it's definitely short.
Yeah. Some of them are quite nice. I like the student quite a bit, right?
Yeah.
If you're used to doing pattern matching in F# or other languages, this is quite lovely.
It's one of the things that it's a little. I mean, there's a reason we didn't do it up front, other than we didn't have time. I mean,
Yeah, it's always a real
it's a little alien to get into recursive patterns. It takes it a little getting used to, but it gets very addictive, and it might actually make you a functional programmer. So beware.
Yeah.
All
right.
Anyway, there's patterns. These are sort of the main features we're thinking about for patterns in C# 8. There might be a few more, but this is sort of the main bulk of it. The expressions and the switch expressions and the recursive patterns. All right.
Next new feature.
Up, home on the range.
Oh, next new feature is range
Yeah.
expressions. So I've got some code here. Actually, I'm going to collapse this one because we don't care about it. It's printing a string. How many people have written code like this before? Like, all I want to do is check and see if it's got double quotes and then remove the double quotes. Anybody write that ever in their lives? Yeah.
Yeah, that's like
You're
4
all
people who wrote that
lying
before.
that aren't raising your hands.
The rest are
Everybody
just
writes
lying.
code like this. And one of the things that I personally hate about it is the fact that right here, if I want to get the last character of something, I always have to go like, oh yeah, text.length -1. Right? It just feels like so clunky and cumbersome sometimes. Wouldn't it be nice if I didn't have to do that, right? Oh, I blame you. But you were also my savior because this was kind of your idea. But the idea that I could, instead of passing in, an int index, I could pass in something, some other operator, right? And so one of the things we're playing around with right now is a new kind of unary operator using the hat character, where that will say, no, you know what, I actually want this, but count from the end. Okay, this is an index, but I want to get it from the end, okay? And so now, this actually returns a system.index, which is special new system type that we're looking at and we're playing around with. But the idea behind this thing is that it can be either counting from the start of some array-like data structure, like starting from 0, or it can count from the end of that, okay? And allows you to do some nice indexing kinds of things here.
So a normal int just converts in, we think. We didn't actually write
I didn't even try it, yeah.
But can just convert into an index. But you can also use a hat operator, and then you get an index that's a from-end index.
Yeah.
Has an int inside and the bool that says where this actually goes from end.
Now, it's kind of nice because this thing also, because it's backed by a real type, I can assign it to a variable. I could compute it from something else. This doesn't have to be a literal. This could be, some computed thing where whatever I want on the right side of that. So I can do all sorts of things to kind of figure out how I want to say I want to get to the index into that
Because
array.
it's a type, it's not tied to the indexing either.
Yeah.
You can have indexes that you use for other things, which you often do in method calls. For instance, substring.
Substring, yeah, right down here. So when I run this program, it should strip the quotes, right? Go ahead and do that.
Oops.
Oh.
It didn't.
Yeah.
What's wrong?
Because there's an off by 1 error. Because when I strip quotes, this is not -1, but I want -2.
Oh, that's
That really is kind of horrible. What would be really great if I could write that same index here. I can't. It turns out there's simply, I can't, because there's no overload of substring, it takes an index in this position. So I'd have to, it wants to convert to int. That's not possible because it would be from end. So how would you represent that?
Yeah, we could build an overload, but we could also.
Yes, we can also introduce. So one of the there's an overload on here that we kind of hacked in for a type called range. Okay, and range can look exactly like that. Okay. And so this is a range from index 1 and whatever the length of this is back by 1. So now when I run this, and that's, by the way, that's exclusive, so it gets the -2 on there. That's an exclusive end to that, right? And so that addresses that. Now, of course, substring's nice, and there should be an overload here, but where these also become very powerful if you want to use them in indexes, right? And so that'll produce the same thing.
Now you essentially have a slicing syntax here, a substring syntax.
Yeah. So that's kind of the heart of ranges, though. I mean, we're playing with text. Where this really starts to shine is in arrays. As we're talking about slices and arrays and spans, it really, they really work quite well with spans themselves. So this is the same code that you guys saw earlier as we were doing the span demo, or at least the start of that code. It's not hard to imagine if if in fact I have this on the machine where I can say array and I could get back a slice like that. Now the difference between this and this span slicing method is span slice takes a start and a length. This takes a start and an end. So it should return kind of the middle, like starting at index 4, it should return 4 more elements. This is, again, it's end exclusive. So 8 is not included in that range as an index. Which is consistent and natural with how you index into arrays already being 0-based. So if I run that, you'll see that, and I can go to the slice and run it again. You see just those 4.
It gets the exclusive range from 4 to 8 there.
Now, it does become a problem, though, when you want to say, like, oh, I just want to go from, say, index 4, and I just want the whole rest of the array.
Right. You could say hat 0, I guess.
I could say hat 0. That looks very fishy.
No, you could do it.
You could do it. But even better, I could just leave that off.
Yeah.
Right? And say just slice all the way to the end, and just give me everything to the end of the array. Likewise, I can put that 8 back in if I want it from all the way from the start, which in this case is going to be 0, but it might be something that's some other data structure that's different, and I could just have it up there and it just goes all the way up to 8. Or I could just leave them both off.
And you get the whole thing.
I know this looks funny.
Yeah, so you might say, okay, why would I want to slice the whole thing, right? I've got the whole thing already, right? But one of the places that we foresee this being very useful is in multidimensional data structures. Like, for instance, if you're doing deep machine learning, you'll be working with tensor types that are multidimensional arrays. And sometimes you want to slice many dimensions, and it's really awkward to say 0, ... hat 0 on all the ones that you want to leave intact. The ... is kind of a nice abbreviation for that. So we feel like those abbreviations are intuitive. That's also what users of Python tell us, because it's a little stolen from there.
Yeah, it was stolen. It's actually 100% stolen, right? Except that we couldn't do what they do, which is use negative numbers for that. Because if we wanted to use negative numbers, then when you go to index an array with a negative number, well, that has a meaning today, and it means it throws, right? And it'd be very weird if your program not only didn't throw, but kept running with some other random index you didn't expect.
Yeah, so we like having the, and also -0, what does that mean again?
Yeah.
So where Python is sort of like untyped and it works only sort of in an indexing context, we wanted to pull this out into proper strong types that can be applied in any context, not just when you're indexing. And we're really excited to see where this leads.
Yeah.
It's a good combo with span stuff and also with machine learning things.
Yeah. All right. I've got one more prototype.
One more.
Whew. I know.
You still with us?
Every time I type VS in a different folder, it's loading a different VS.
They're all thinking beer.
Yeah, they're like, there's many places where this can fall
12 and a half minutes left.
Yeah, we're actually right on time, too.
Yeah.
All right. So first things first, let's talk a little bit about async. You want to talk about async? Do you care?
Async? Yeah. So async rolled out into C# many years ago, copied by many other languages. Yeah. But there are actually still places where async isn't really well integrated into the language. Two of those is when it comes to the first one of those is when it comes to disposing. Disposal is all about closing things out and cleaning up after yourself before the program moves on. But there's no async way to do that. It's always been dispose is a synchronous method in the iDisposable interface. So we want to simply add an asynchronous version of that interface, iasync disposable.
It looks like this.
Not surprising. Hey, instead of a void returning synchronous method, it's a task returning asynchronous method.
We thought very long and hard about it.
And but then language integrated, so you can using await.
Yeah, so I gave it away already right here. Right, so I'm using await on a long-running disposable. It's just some class I created that implements async disposable. And of course, we're kind of cheating in here, right, by just delaying for a couple of seconds to say, okay, we're going to do something that might take a while. And the interesting thing here is once we create this using block, then we write something to the console. We say, okay, we're going to use this long-running resource, and then at the end of that using block, it should be disposed, which handles the await runs, and it waits for that, and then it prints out, hey, I'm done, and then right down here it will say, okay, I'm finished with the resource. And so it's more of a kind of a run demo than a writing code demo. But this is more showing kind of some of the machinery that's working here, and it lets you just kind of do this very naturally in the language like you'd always wanted to. The idea here is that there's a using, and we say we want to make this using await.
It doesn't actually move on until that asynchronous work has finished up. It does its own await inside there, inside the finally, essentially.
Yeah.
So that's very cool. Another place where the whole idea of async was get away from callback-based programming, which is callback hell. I know that there's still languages that are just adding lambdas now so that they can do callbacks, but we feel like we moved on from that. But when it comes to consuming asynchronous streams, like collections of stuff that beam at you over the wire or are the results of a long-running computation that keeps spewing things out or whatever, we're not actually doing that very well.
Right.
Like, it'd be nice if you could treat asynchronous streams or enumerables the same way you can ordinary synchronous enumerables, like the ones that we use for LINQ and all other kinds of stuff.
Yeah, and so the interfaces we have here, these are early looks at this stuff. I mean, there's a lot of testing going on and figuring out what it's ultimately going to be. And hopefully you don't really have to use these very often. Hopefully you're writing async iterators, which are not in the prototype.
Yes, you don't have to implement the interface very often.
Yeah.
But the language integration that you want for these is the same you want for enumerable. You want A, to be able to for each them, and B, to be able to, so consumption, and B, you want production in the shape of iterators, which are not part of this prototype. Oops.
Just a warning.
But we do have the for each part implemented, right? So we have an asynchronous stream. We want for each over it.
Yeah. So the way this, I'll show how this program works. So basically, this program is calling this method which creates a stream. Okay. And so all it's doing is creating a big byte array. Okay, 20,000 bytes, and it goes through and fills it up with the index modded by the max value of a byte. So it's filling it up with values from 0 to 255, and then as it goes, it's calculating a checksum, which is just a long that it's going and adding each value to. So it says here's the checksum. Okay, it's doing it in an unchecked fashion, so it'll overflow around to 0 if it has to. And then I create a stream, a memory stream from those bytes, and I return it. Okay, I return these values as a tuple. Now, on the flip side, we take that stream, and I call this method as enumerable. Okay, this is just an extension method. I created all of this afternoon. Okay, just so there's an extension method over here.
Because the bits worked yesterday.
Yeah. So the idea behind this async enumerable interface is that it will allow you to do kind of buffering or chunking as you bring in data, right? So I want to go off and if I'm hitting the network or I'm hitting a disk, I want to bring in a piece of that data, and then there's a faster synchronous method that can go over that data and return things very quickly from it before it needs to go wait and bring in the next one. So you can kind of set that up and say I'm bringing in the next piece while it's actually enumerating in my program and pulling the data in. So and so what this does is the asynchronous stream does it in 8 kilobyte chunks. It's going to pull from this memory stream. In here, I also have an await so that it on a task delay, so you can see that it's going to take a little bit of extra time, and then it's going to have some pauses. And then as it's doing that, it's calculating the checksum, right? Again, to make sure that we get back all the same bytes and the checksums match at the very end.
So just to be clear, Dustin said all kinds of complicated stuff.
Did I?
But what it really means is the for each just does things for you. Like it just iterates, and whatever magic is under the hood, that's fine. The language integration part of it is just that it is able to await whenever there's something that isn't there yet.
Yeah. So I'm going to go ahead and run this, and you can see it work. This is actually so we're looking at putting out some prototypes, some previews of some new things. This one is not ready yet, but we've got for each await and we've got using await, and it's pretty exciting. So here it is working. The stream was actually disposed through async disposable because the for each does that for you. I didn't have to do it, and the checksums match. So that is a little bit on async streams.
Right. So that's sort of the hardest bits. You can't get those. All the other features we showed are in publicly available prototypes. So I think we'll go back to slides.
Yeah.
Talk about a few more features that we don't have prototypes for yet, at least that we can share, but that are also likely candidates for things we will do in C# 8. So one we actually showed a very early prototype of last year, and it's mostly just been sitting there, but and sort of being kept up to date with the bits. But that's one that we're still pretty eager to do, which is default interface members. So this is some interface that's being implemented by a class. And now, as the owner of that interface, I'm like, I really wish that it had another member. Okay? But if you evolve an interface, if you put another member in it, well, then you're breaking all the existing implementers.
That's why you see a lot of iLogger 2s out there, right?
Yeah.
And
So people just abandon their interface, and it's a mess. So we want to allow you to add new members to your interface as long as you provide a backup implementation for all the people who didn't know about it when they implemented the interface, or who just think that's a perfectly great implementation, they'll just keep that. So you can put an actual method body on a method in an interface now. That's what we call a default interface member implementation. So here I'm adding another overload of log, and I'm just giving a default implementation. So console logger is fine, even though the code might never have been touched since. It might not have been compiled since like 3 years ago. Doesn't matter. It's going to work. So there's some runtime work here for that to work without recompilation. That's an interesting twist to this feature, by the way, which is that we need to change the runtime for it. So we haven't done that in a long time, since generics pretty much. And the interesting challenges are not so much, well, we can work with the runtime, we can change it, but it's like, how do we roll that out and make sure, how do you know that everybody has it and so on. So it's a little bit of a challenge there, but we'll work on that. Of course, you could also, if you choose, you can also actually implement both of those interface methods, and then the default implementation just doesn't do anything. So we think that's a useful little addition. It's a little weird for some people to see actual code inside of an interface. There's some pushback on that, but I think that it's worth the price in order to get freedom to evolve interfaces as you think of more things they should be able to do.
Yeah.
Okay, so that's one. There was a single
smattering of clapping.
Okay, yeah. Okay, thank you. You think so too, some of you at least, or you're just very friendly. There's also another thing that we've been thinking about, which is we keep coming back to, which is we like C# is an object-oriented imperative language. This mutation and state changes are sort of at the heart of the good old-fashioned object-oriented paradigm. We've been trying to pull in more functional idioms, and you can do that in C#. And for instance, we built the whole Roslyn API. We built that as immutable classes so there's no mutation, and they're value-based, so they compare equals based on what's in them, not based on reference and so on. So, but we kind of have all the wrong defaults in the language for doing that. So you have to do a lot of work to write immutable data-like classes. And we're like, what if there was just a syntax for doing all of that? So maybe you said something like that, or maybe there's a record keyword or something, and you just list some types and identifiers, and it generates all of that, right? That might be kind of cool. Like, it generates properties that are immutable by default. It generates a constructor. It generates a deconstructor. It generates equality implementations and hash code. Maybe, not shown here, maybe we've been talking about supporting automatic withers, where we would either generate methods per property, or we would have some other mechanism for giving it methods for what they call non-destructive mutation, where you say, I want one just like that one, but with this property changed to this other value, right? Maybe there are methods in there to support that. You don't have to handwrite those. So this would sort of be like flip all the defaults and do the opposite thing. And then maybe you can give it a body to adjust what happens in there and add additional members and so on. So that's another thing we're thinking about. But thank you. There are a few more things on the docket, and you should go to the C# Lang repo under the .NET organization in GitHub. This points specifically to the wiki, because that links to the two landing pages for the two prototypes. I said we had 3 features, but 2 of them are actually in the same prototype. So there's one for nullable, which reflects one branch in our code tree currently, and there's another one for the ranges and what was the other one? The pattern matching features. They're merged together into one. You can go, there are installation instructions, and rapidly growing known issues lists and everything. So if you're courageous, please go and try this and give us feedback.
Yeah.
We really, really appreciate that. And it really, like we did it for Nullable. The other one is new, but for Nullable, it came out in November the first time. It really, really helped us shape it. Like we did lots of changes because of the feedback we got. Please, please, please do. This is how the features become great.
Yeah,
so,
and to be clear, that Nullable preview that's here today, that one is an update to that. So if you've used the Nullable preview, there's a brand new one, and some of the things like we showed here today where you can turn off a particular set of warnings for porting code is helpful.
And for the C# 7, 1, 2, 3 features, check the docs. 7.3 isn't quite up yet, I think, but the rest of them are there. 7.3 will come soon. So please enjoy. Thank you very much, and thanks for coming.
Thanks, guys.